Hello everyone. Welcome to the introductory course on database systems CS 301. Okay, just a brief slide on the course logistics. So as of now, we have two teaching assistants. Probably we'll get more. Hopefully we'll get more because this is likely to be a big class, and I believe entire third year computer science is sitting in this class, and probably some people from the CS minor as well. So hopefully we'll get more teaching assistants. And regarding the textbook, we have sort of three textbooks for this course. Primarily, I'll be using the textbook from written by Silver, Sats, Korth, and Sudarshan. And for one or two topics, we'll be using this book from Ullman, Database Systems, the complete edition. So I do have a soft copy for both these textbooks because I don't think you will be able to access the library because many of you would be taking this course from your home. Right, so we will try to get soft copies of both these books, and you yourself can do a quick Google search. These are very widely popular textbooks. Somebody or the other always puts a PDF on the web. The third book is only for your reference. We'll not specifically cover anything from here, but in case you are confused with some material in these books, you can always refer to this third book by Nawate. Okay, so the course deliverables. So given that this course is going to be held in an online mode, we'll have to see how much we can do. So as per the current norms, I believe I should have a final exam worth 40%, and most likely this final exam, many of you will be able to come and give the exam on campus, right? And given that this is 40%, most likely this is going to cover a major chunk of the syllabus, right? Apart from that, there will be a midterm exam and some quizzes. So the way we are going to run our quizzes and slash midterm is that I'll give you a question paper, and I'll give you maybe 2 hours or so, and you are supposed to write all your answers on a simple plain sheet of paper, and at the end of the exam you have to scan that using your cam scanner or something, and then upload it onto the Moodle, right? So that's most likely that is how we are going to conduct the exams. The reason I'm going for this is because the material in this course, it's not really suitable for an bubble or multiple choice kind of a questions, right? So that's why I'm going for this. Normally I have some lab tests, but again unfortunately we cannot run lab tests. So the way we are going to do is I'll request you all to install some set of softwares. These set of softwares are, again they are free to download, and you will, so on those softwares, so these will be database softwares. Postgres, will install Postgres on your computers. I'll give you some test data and all that, and I'll give you some practice labs. So now you're not going to grade the practice labs, but at this stage you have to be mature enough and honest enough to actually try all those SQL queries on your own. And then we will of course have live sessions with me and the TS, wherein you can ask questions on if you are stuck in the SQL queries or something like that, right? So there has to be a good amount of honesty from your side, right? I hope you understand that. And apart from that, there will be one major piece of work which you will have to submit, and that's the database application project. So this project will be done in sizes of 2 or 3, where that you'll have to design a back end, you have to design a front end, you have to connect both of them, right? There will be a little bit relational database, there will be little bit of MongoDB also, depending on how much we are able to cover and all that, right? So this is roughly the set of deliverables for this particular course. If there are any updates, I'll let you know. Okay, policies. So the standard, dishonesty policies of IIT Ropar would apply to this course. And if you are caught in academic dishonesty in any of the deliverable, if the weight of that deliverable was X%, you would be given minus X% for that deliverable, right? And makeup exam or makeup quiz is not guaranteed until and unless you get an approval from Dean Academics, right? And makeup exams will cover significantly more syllabus than the original quiz. That's the only way it is fair, right? And then I also have some late submission policies, right? So, given that we are conducting this course online, a lot of quizzes and exams will be conducted online, right? Where, as I said before, you'll have to write your answers on a sheet of white paper and then, upload onto the Moodle before the deadline. So now, in order to prevent unauthorized collaboration, what I'm going to do is that I'm going to have a very strict late submission policy. So that means if the exam is ending at 9 o'clock, you have to upload your answer sheet at 9 o'clock. Even if you are late by 5 minutes or 10 minutes, I am going to put some amount of penalty. Okay, so that's how it is going to be. I hope you all understand why I'm putting this penalty, right? Because it has to be an individual effort. I'll strictly give you the examination at a time, and then when the set duration expires, you have to immediately upload. Late submissions are not allowed, or there will be a significant penalty for late submissions. Okay, so that's about the just a quick overview of the logistics and the administrative details of the course. Now we are going to get into the actual topics, right? So let me start with an overview of database systems. Right? So what is a database system? So database system, it's it's obviously software, but if you go into high end, a database system actually comprises of software and hardware both. There is something called as data appliance, where hardware and the software are they're sort of sold together. But most likely, but in an for this particular course, you can imagine database to be some kind of an enterprise level software where you collect and manage the data for any one particular enterprise, right? So the software manages a collection of the data, and that data has some kind of an relationship with each other, and then you have a set of programs to access that data, and the focus is always on the convenience and efficiency. Just to give you a simple example here, you all must have used the course registration portal for registering courses and all that, right? So CRP is a very simple example of a database system, right? Now what has happened over the years is that initially when we called a database system, people used to design the front part of it, that means what data to collect, how to organize their data, and they also uh, had designed the back portion of it, like what kind of a query optimizer we should have and all that, right? What kind of an efficient algorithms that we should have to access the data. But starting from 1980 or so, what companies have done is the database system, the notion of database system is sort of broken down into two parts. So the one part is what you can call as the backend of a database system, right? So in that backend, you have all the software which will manage your data and all that, right? So if you pick any distribution, Oracle, Postgres and all that, they all are examples of database systems which are sort of managing the back portion. They have extremely efficient query processing algorithms, and they have indexes to index on your data and all that, and then you use that database system to actually model your business logic, whichever that you want to use. So for example, in your CRP case, your business logic is all concerned about how to manage courses, how to add grades and all that. So that's the front portion or the business logic part of your database application, right? So with the advent of all these data companies, Oracle, Microsoft SQL Server and all that, so these two have got separated. The vendors, they sell only the bare software, and then people are they use that database, and they design all their front end and business logic, and they sort of launch the application. So more on this as we go forward, but just to give you an idea on what database system uh, typically has, right? You can think of many examples. You have database applications, uh, in banking, airlines and all that, right? So to maintain clarity, what we are going to say is all of the front end part, which I was saying, that business logic part, let's call that as a database application, right, in this course. And all the back end portion means the query processing, or a typical a typical database system from companies like Oracle or Postgres. We'll call all of that as the DBMS, the systems part, right? And the application part is more on the business logic. So for this course, let's have that segregation. Okay. Okay, just a pointer that database systems are still a very active area of research, uh, and the scalability is one of the prime requirements of this, right? Okay, so let's go forward. Okay, so just to give you an idea on where did this come from. So if you go back some 40 years, that means in 1970s and 1960s, the earlier all of these applications, they did not have that segregation of the business logic and the backend query optimizer and all that. It all was built into just one massive system. There was no segregation of the front and the back portion, right? So in that case, what used to happen is that you know things were not easy. So what let's say that you built a CRP and you did not have a database system with you. So now what happens is that you have to write all the extra code that you need to access the data, to index the data, and many times key aspects which are extremely important to your business logic. For example, if you are constructing a CRP, right? So there is a business logic constraint which says that a student should not take more than 26 credits. Now, things like this, the integrity constraints or the business logic constraints, they get buried too much into the program code, right? So as a result, what happened was that adding new constraints or changing the business logic becomes extremely cumbersome, right? So the same set of coders and designers, they have to worry both about the business logic and the back end of the system, wherein they are concerned about performance and index structures and all that. So this was highly coupled, and it could not grow, and it's prone to errors, and the scalability also becomes a challenge sometime, right? It's a massive affair to maintain a monolithic system like that. So then what happened is, so this was the case in 1970s and before. They used to have just one monolithic system which sort of put together both the business logic and the back-end portion for accessing the data and all that, right? But in 1970s, an influential person named Cod came up with a theory called as relational theory, right? Or relational algebra, if you want to have it a slightly different name. So I'll give you the exact name. I think it's okay. So it's called as relational model. So in the relational model, what we have is that all of the data is actually represented in terms of tuples, which are grouped into something called as relations. He proposed was that he studied a lot of this information management systems that were around at that time, something like business, something like airline reservation system, academic management system, and all that. And after studying all of this, what he realized that all of the major operations, they can actually be summarized by using just three operators, and those three operators are select, project, and join, right? And all of the data, which typically these applications have, they can be modeled in something what we call as tables, right? And all of the logic can be simply be defined in terms of three operators, which are select, project, and join. So this was a highly influential paper at the time of 1970s. So before that, the notion of a database system did not happen. So then the first database system, people picked up this paper and they said that, let's try to build a database system. And building a database system at that time meant that you pick these three operators, select, project, join, and then build a system which sort of, optimizes based on just three operators, right? I believe Ingress was the first database system which was built in UC Berkeley by a gentleman named Michael Stonebreaker. Both Cord and Stonebreaker got Turing Awards for their work, right? So Cord was the first person to uh, conceptualize that a system like this can be created, which can help in information management area. And then Michael Stonebreaker was the first person to actually take that paper and implement it as a system, and he created Ingress. Then companies picked it up and people did not look back. So the old style of creating a monolithic code for the business logic part and the backend, people just simply gave up on that, right? So nowadays, almost all the database systems which you see, the relational database systems, their goal is only one: construct a system which provides an SQL interface, and it optimizes on the operators select, project, join. This is the basic definition of a database system. And behind that, they will have extremely efficient algorithms for the project operator or for the select operator. They will keep on optimizing or keep on constructing better and better algorithms for these three operators, or maybe more as the people and systems evolve. But with this, the application part, the front end business logic modeling, that got separated completely from the implementation part of the database. All the code optimization, query optimization, all they got separated. Right? So that is how this area came to being, right? So this is the summary statement over here, right? So we people needed to decouple the business logic. That means choice of tables and constraints. The kind of constraints which I was mentioning, that in an academic system you have constraints like students cannot take more than 26 credits and stuff like that. So we had to decouple the business logic from the implementation details. That means, if multiple people are accessing the same data, how will you put locks? Or what kind of an query optimizer will you run? How will you efficiently, scan through terabytes and gigabytes of data? So all that are the implementation details. So database systems are a perfect example which were able to decouple this. And how they could do it? By using that paper from Quartz, because he laid out the mathematical foundation which said that yes, most of the business logic that exists in the world can be reduced to an operation on just using just 3 or 4 operators, and the operands become the tables. All if the data is in tables, where each data record, and we have a notion of tuples and attributes and all that, and then just using those 3 operators, you can model pretty much the entire business logic which was seen at that time, right? So that the cod laid the mathematical foundation, and then the companies picked it up. They created this database systems. It was a success story, and people did not look back. Okay. Okay. So this is a typical schema of a modern uh, database. I should not say just database system, because if you pick a database system, Oracle or Postgres, it is usually the bottom 2 parts, logical model and physical model, whereas all of business logic actually comes here. But largely, if you pick a database, right, the topics are spread across three modules. So one is conceptual modeling, the second is logical modeling, and the third one is physical model. Right? So in the conceptual modeling part, as I said, this is primarily used to capture all of your business logic, right? And at this stage, we have things like ER diagrams, UML diagrams, anything which is primarily for consumption of humans, right? So this is the front end part. So at the logical model, what we do is that we encode all of the application related concepts into relational tables, relational operators, and all of that, right? So from logical model itself, from the logical model, we start a typical database system which is available, right? So here we have things like relational algebra and all that. We'll cover those things in detail. And last but not the least, we have the physical model. So in that physical model, what we do is that we pick operators from the logical model, and we develop scalable algorithms for that, right? So this is what it is written: implement the mathematical concepts into an scalable system code which works on a variety of data sets, right? So the logical and the physical model, which is shown in this figure, the modern day vendor, Oracle or Postgres or Microsoft SQL, they focus mostly on these two, and the conceptual modeling part is left to the application developer. So given any business problem, we people will start going through the business logic. They will encode all of that business logic first using a conceptual model, and then they will pick up a database system, and they will convert all of their business logic into this relational algebra operators and all of this, right? And then the database system from the backend takes care of it, right? So this is the typical breaking. So if somebody has to create a business software like an enterprise resource software and all that, the top part is taken care of by the people, and then they encode all the business logic into the logical model. By that I mean that they convert all their business logic into a set of SQL queries, and all of that, and then the physical model just takes care of how to efficiently run those SQL queries. So in this course, I'll focus more on the top two portions because this is an undergraduate level. I will cover physical model also, but physical model is so huge because here we actually get into the details of a database system. I will cover query optimization, concurrency control, and a good amount of that. At least 1/3 of the course will be on physical model. At least I teach about a month on this. But what I teach in physical model is only the introduction on what all actually goes into a database system. For getting the details, I have another course called as database system implementation, where I cover only the physical model exclusively. So So if you are interested, you should register for that course later on. So in this course, I think I have a list of topics here. Yeah. So we'll start with the relational data model, which is the data model, which was originally proposed by Cord. You remember all those three operators that I was telling you: select, project, join. So we'll start with that. And initially, what I would do is that I will explain those operators, and I will give you examples on how business logic can be encoded using those operators, right? So we'll model all of our data as sets, and then using these three operators we'll show that pretty much any query that you can have on your data can be written in a combination of using those operators, right? So after we are done with relational data model, we'll cover SQL queries. So this is very important part. uh, so here we'll practice a lot of SQL queries, and we will try to run them on an actual database system. So the topic wise, I'm doing little bit out of order execution. Ideally I should have covered ER models first week, because these are the conceptual models, but I'll start with relational data model and SQL, because I would like you to spend more time on these, because this is what is actually useful in in your placement interviews and all that. Okay, so then so I'll do a little bit of out of order execution here, right? And then I'll cover normalization, which is basically theory of how to design good tables and all that. So this is the theory part mostly, right? uh, and I forgot one thing. So in conceptual models, what I'm going to teach you is how to design your database, right? So how to encode business logic into a set of tables. This is very important from the perspective of your course project, because in your course project, what I'll give you is that I'll just give you an English description of a business use case, and then it would be your task to actually take that business use case and convert it into a set of tables and queries. How are you going to how are you going to spread that data into different tables and all that. So this model, you should you know it I know your seniors and your super seniors, they all felt that this is little boring, but trust me, this is one of the most important uh, topics when you are going on to the real world. People are interested in this access methods, query processing and all that, but you would not be touching query processing algorithms until and unless you are actually sitting in Oracle or Microsoft SQL Server. Any front end based company which designs database applications, they would test your these are the four topics which you would actually be needing, because database is like a tool. You have to use that tool, right? So you should know how to use that tool nicely, and you will be able to use that as a tool if you know the first half of the course very nicely. The second half of the course is actually the details of what goes inside the tool, right? So this all this transaction and query processing algorithms, they are interesting from a computer science perspective. Given that you all are from computer science, you should know them. And you also get a feeling of when you try to design a software at large scale, what kind of things can go wrong, right? So go, those are the kind of things which we'll cover here. Of course, if you are getting into companies like Oracle, even Microsoft, MongoDB, all these data related companies, these the lower four are extremely important for you, right? Okay, right. So don't think that one is more important than the other. All the topics are important. It's just that their importance is more prevalent in some companies than the others. Okay. Okay. So I think I'll stop here for the introductory video.